In today's lesson, we are going to be looking at a one variable analysis. So this is going to be helping us with our culminating task. And basically we're going to be looking at now how to analyze data. In the previous lesson, we looked at how to collect data, the different kind of types of data that we could collect, some of the bias that might be involved in collecting data. But now we're going to look at how to analyze it, which would be the next step. So first thing we're going to look at today is measures of central tendency. So this is one of the tests or the statistical values that we can find that can help us analyze. And the measures of central tendency, you've probably heard of them before. They refer to a central or common value. Sometimes they can be classified as summary statistics because they summarize a data set. They summarize what we're looking for. And generally, it represents the middle of the data. Right? We're talking about the central value. We're talking about what does the middle look like. And the three types would be mean, median, and mode, which I'm sure you've heard of before. If not, we are going to go over them again. So the first one is the mean, and mean is also known as the average. And we can calculate the mean by adding up all of the numbers and dividing by how many, or the total number of data points, or how many there are. Right? So you add up all the numbers and divide by how many there are. And the mean represents all values of the data set, again, because it's including all of them. And we have our two formulas here. Again, there's nothing too complicated about it. Right? Remember this giant E-looking symbol, sigma, means the sum of, and then sum of each x or each data point divided by the total number of numbers, or the n's, equals our mean. And we have two different ones. We have this letter, and this is a Greek letter mu. And all it's referring to is just the mean, but this is the population mean. So if our data set is referring to the population, we would use this formula. It doesn't really change how we solve it, just changes some of the notation, which then gets carried on in some of the other formulas that we're going to look at later. The other one, same, again, formula, just slightly different notation. We have in this case what we call x bar, and this is the sample mean. So the formula is still the same, it's just depending on what we're looking at. Right? The population or the sample, we use slightly different formulas, just to differentiate between the two, because in some cases there are different formulas whether you're looking at the population or the sample. Not what we're going to be looking at today, but in future lessons we will see that. So we have mu or x bar, which are our two symbols to represent the mean. Then just a little comment on how the mean can be misrepresented, right? So we're talking about starting salary. One individual is saying that the starting salary is $80,000, but when we look at how that's actually broken down, we can see that most people are making $30,000, except for one individual who's making a lot more, which is increasing the average. Right? So when we talked about the average including all values or representing all values, it does that in either a good or a bad way. Right? We can see that the CEO's son, that value is heavily inflating our average, which might not represent the actual starting salary. Next is the median. And the median is the data point that lies in the middle of the data set when ordered. Right? So that's a key thing. We need to make sure that our data is ordered from lowest to highest, and then we find whichever one is in the middle. Right? If n is odd, right? So if the number of values we have is odd, then the median is the middle value. If the number of data points or numbers that we have is even, the median is the average of the two middle numbers. Right? And it's sometimes referred to as the 50th percentile, which we'll refer to later in a future lesson. So again, with the median, why should I invest with you? Well, not to brag, but my fund has a median gain of 8% per year. 8% doesn't sound too bad, right? It's increasing, which is good. But when we look at the actual values, we can see that the median might not represent the actual what's actually happening, right? Yes, the middle number might be positive, but we can see that the negatives greatly outweigh whatever increase you have. So the median can also be a bit misleading as well. Lastly, we have the mode, and the mode is the data point or the value that shows up the most. And there are some kind of specific scenarios depending on what could happen. If all data points are unique, then there is no mode. Right? So if everything is unique, there's no repeats, no double ups, no triples, whatever, we say there's no mode. If there is a tie, all values that are tied are the mode, right? So if we have, say, 10 numbers and we have 2 3s and 2 4s and the rest are all individual numbers, then we'd say that 3 and 4 are the mode, right? So you can have multiple modes. And this is most useful when looking at nominal categorical data, right? Which value occurs the most, right? Which sports team is the favorite, which type of sport, which color, what animal do people prefer, right? So the mode is important when we're looking at what matters most, or when the number that comes up the most is what's most important, right? Say if you're looking for a class, like seeing what happens in class, maybe the mark that comes up the most isn't that important, right? Especially if it's only two people rather than out of 26, say, right? So again, they all measure some sort of like central value. Different ones might be better given the scenario. With the mode, we might have a modal interval, which is the interval of data points that shows up the most, right? So if we're looking at things where we have an interval of data rather than individual points, then we look at which modal category has the most or the highest frequency within that. So again, how the mode can be misrepresented. So how are you doing on your tests? My modal category is 70 to 80. Then he says, or they say, please do not ask about the mean. Right? So their modal category is in the 70s, 70 to 80s. They're not wrong about that, right? We do see that this is most occurring. However, it's not a good representation because it's only one more than all the other categories, and all the other categories tend to be lower, right? So the mode might not be the best representation for this type of data. Right, so let's look at calculating this, right? So given the table of employee incomes below, calculate the mean, median, and mode, right? So if we go through, the mean is the average. Right, so we need to add all of these values up. So 34,983 plus 18,980 plus so on, all the way till we get to plus 2432. Right, all of those values get added up, and we're going to divide by 15 because that's how many values we have. We have 15 values. So this works out to 1102,774. So 1,102,774 divided by 15, and we get 73,518.27. So that is our average. And in this case, we don't need to round, right? Whenever we're dealing with mean, median, modes, we don't need to round to get different values. Right? We can leave it with the decimal. Now we might want to round to a certain number of decimal places, right? Say 2, but we don't need to round to the nearest whole number. The median, the next thing that we have to do, right? The median, we need to put them in order from lowest to highest, and we've done that in our table. Now what we can do, a nice easy thing, is we can, instead of counting to the middle, right? So what you might do is you might say, okay, well, cross one off on either end and work your way through to the middle, right? There's nothing wrong with doing that. Right? We keep on going and we get our middle value. Right? What we could also do though is if we know how many data points we have, right? We have 15 data points. We're going to divide that in half. We get 7.5. So that means we take the eighth value, right? Because basically it's saying 7.5 is we don't have an even number of numbers, right? So 7 and 7 on either side, and we have one data point in the middle, right? So that means we would take the eighth, so we count to the middle. 1, 2, 3, 4, 5, 6, 7, 8. We add that, we take that value. Therefore, our median value or income is 33,450. The mode, right? Again, the mode is probably the easiest one to find. Remember, the mode is the one that is most occurring. So if we go through and we look at all of our values, it's a little bit easier when it's all ordered. We can see that 12,500 is the most occurring. Now, when we went through and did that, are there any outliers, and did they affect the previous calculations? Right? So did they affect the previous calculations? Right? I would say if we go back and we look at our table, I would say there are two outliers. Right? There are two values that seem like they don't fit the trend or they don't fit with the other values, and those would be these two values here. Right? The 250,000 and the 478,000. Those don't fit, right? Those are almost 100, a minimum of 100 and say 100 or 200,000 difference, or 400,000 in difference. Right? So those two are outliers that we would say. Right? So 250, 921, and 478, 320 are outliers. Right? So how do they affect the previous calculations? Now you could go back and you could actually recalculate the mean, median, and mode. Right? It probably wouldn't affect them, or it might affect the median. It wouldn't affect the mode, but it would affect the mean, right? Because the mean is influenced by all the values. So how might it affect the previous calculations? The mean would be increased, or the average. So the mean would be increased due to the high outliers. The median would also be increased, or would be affected. And the reason I say the median would be affected, right, even though the values don't actually affect the median, right, because the median is just a value that we already have, or just the average of two middle values, which neither of these are. They're both on the same side. They're both on the high side, right? So if we remove them and I'm counting towards the middle, it's going to affect where I go, right? If I had a high value and a low value and I counted my way to the middle, it wouldn't really affect it as much. Right? So the median would be affected as well. So which measures of central tendency best represents the income of employees? Right, so this one might be a little bit subjective, depending on what you look at. But I think based on what we said previously, if we weren't removing the outliers, which we can't really do, because they are part of our data, right? They are salaries, they are incomes of employees in our data, so we can't really remove them. We could remove them, say obviously they're outliers. So they're separate from the trend if we're looking for a trend. But if we're just trying to calculate the median, or trying to just analyze it, we can't really remove them. Think of it as if I'm looking at, say, class average or class median or class mode, I can't remove two students' marks just because they're really high or they're really low. I still need to include them. But I can choose which measure I think is best going to represent the data. So in this case, I would say the median best represents the data or the incomes, right? And the reason I say that is because the mean is influenced. The mean is influenced by the outliers. Yes, the median is influenced by the outliers as well, but not to the degree that the mean is, right? The median is only affected by one or two positions, right? Which is a nice thing about the median. It doesn't get affected by those extreme highs and extreme lows. They're just values or placeholders, right? And we're just counting to the middle. And usually our extremes wouldn't be in the middle of our data set. They'd be on the either end, which they would get eliminated when we try to calculate the median. So if you do have outliers, the median does tend to be the better value. Not that the mean's wrong, but it might be misrepresenting. Now we can use Google Sheets to calculate the mean, median, and mode. It is a relatively straightforward calculation. So if you're ever using Google Sheets or Excel, it's the same formulas. You're going to type in equal into one of the cells, and then you're going to type in average, or start to type in average, and you might see it pop up. You can double click on it. It will give you an option to highlight the cells or the data that you want to include or find the average of, or the median or the mode. And that's what these brackets represent. The data goes here. Or say the cells with data go here. Let me just rewrite that all together. Cells or boxes. So cells with data go here. So when you highlight it, it's basically going to give you coordinates or basically values. So if I look at the table, right, if I wanted to calculate the mean of the population, I don't want to add all those numbers. It's a lot of numbers. They are long. So I'm just going to use Excel. So I would highlight that. It would tell me that my values go from, in this case, it would be equal average. And it would say B2 to B12. So that's basically saying find the average of all the numbers in B2 to B12. And if I highlighted a different thing, it might be C2 to C12, D2 to D12, things like that. The same thing apply when I'm looking at the median or the mode. Same idea, right? We start to enter in a blank cell in an empty space. We type in equals, start to type in median, and go through and highlight the data that we want to find the median of and the mode of as well. But we'll look at that in a later lesson. We'll go through and actually kind of do those calculations. The next example we're going to look at, we're going to be looking at the time taken to complete a chess game that was recorded. And this is going to be a little bit different because we're going to be looking at data that's placed into intervals. Right? So we're looking at continuous data because we're looking at time. So it's easier to put that data into intervals because you won't find a lot of values that have the exact same time, right? Because the data is continuous. There's infinite possible values for time. So when we have data like that, when we have data that's been put into intervals, it's a little bit harder to calculate the mean, median, and mode because we don't know what the actual values are, or we don't know what the actual individual data points are, right? It's all aggregate data. It's all been grouped together and summarized. We don't see the micro data. So what we do, and that's the case, we're going to basically estimate the mean, median, and mode. We're still going to calculate, but we're going to estimate based on what we know. Right? And we're going to estimate it by using the midpoint value of each interval rather than the actual data points. Right? So when we look at each interval, we're actually going to use the midpoint. So for example, if I look at the interval of 10 to 15, the median is 12.5. Or the middle value, or the midpoint of those two is 12.5. So that's the value we're going to use to represent. And the frequency tells us that we have two of them. So we have 12.5, 12.5. For the next one, 15 to 20, the median or the midpoint of those two would be 17.5. And then the 20 tells us that we have 17.5, 20 times. Then we move on to the next category, the midpoint of 20 to 25, and so on and so on and so on. So that's how we can estimate the mean or estimate the values when we're given a frequency table or intervals. Formula is still roughly the same, right? X bar equals the sum of the frequency times the midpoint, right? Because instead of adding up 12 plus 12, we can do 12.5 plus 12.5. We can do 12.5 times 2 plus 17.5 times 20. Right? So if I was to expand this, what it would look like would be the frequency, so 2 times the midpoint, which is 12.5, plus the sum of the next, which would be 20 frequency times 17.5, plus the next one, if we really wanted to, 18 times 22.5, and so on, all divided by how many there are, right? Which is the sum of the frequencies. So 2 plus 20 plus 18, so that's 40, so it's 55. So we'd end up dividing by 55, which is the sum of the frequencies, basically meaning that there are 55 data points. Now, when we go through and calculate something like that, it might be helpful to create a table, right? Just to kind of organize our calculations, organize our thinking, right? So our midpoints, we already mentioned 2 of them, 12 or 3 of them, 12.5, 17.5, 22.5, 27.5, and 32.5. Nice, easier numbers to work with, again, because we had nice intervals. So what we do, because it's the sum of, and we can see the formula still at the top, the sum of the frequency times the midpoint, I need to multiply, each midpoint by the frequency. So I need to go through, multiply all those values. 12.5 times 2 is 25. 17.5 times 20 is 350. Then we have 22.5 times 18, which is 405. 275, and 162.5. Cumulative frequency, so that is basically adding up as we go. So right now we have 2, then we have 22 data points in total because with the previous 2 intervals plus the 20. Then we have 40. Then we have 50. Then we have 55 at the end. And this is going to be important. We'll come back to that in a second. But again, the goal for this is calculating the mean. So if it's X bar equals the sum of Fi times Mi divided by Fi, we are basically going to add up all of this column. This column is all going to be added up for the sum. So we have 25 plus 350 plus 405 plus 275 plus 162.5, not a comma, plus all divided by 55, which is the frequency or the sum of the frequencies. So that's right there. That is your Fi. And when we go through and calculate, we end up with 1,217 divided, or 0.5 divided by 55, which gives us a value of approximately 22.14. So our approximate average, or our approximate mean, is 22.14. And so our approximate or estimated value, because we're estimating based off of the midpoints of the intervals. We don't know the actual data points, right? So that mean could be higher, it could be lower, depending on what our actual data points are. But in our case, we don't know, so this is the best that we can do. When we're looking for the median's a little bit different, right? A little bit different. We can still do the same thing. We can still look for the right term number. If I have 55 data points, I'm going to divide by 2 to find the middle. I get 27.5. So I want to look for the 28th data point. So I'm going to look for the 28th data point, right? So if I go back, I'm going to look at my frequency or my cumulative frequency here. And where would the 28th data point fall? Well, that's where the cumulative frequency comes into play, right? Here I have two values, right? So there's two numbers in there, right? So that's not 28. 28th data point wouldn't be there. I now have 22 data points in the second column, right? It's not in the first one. I have 22 now in the second. I'm still not at my 28th data point. I see now I have 40 data points in the next one, right? I'm up to 40. My cumulative number is 40. So because I'm looking for the 28th, it wasn't in the first two intervals. It has to fall within the third interval because my cumulative frequency is greater than the data point I'm looking for. So 28th data point is in this interval. So the 28th data point is in this interval. So that means our median, we're estimating again, would be 22.5, right? Because again, we're using the midpoints as our markers, as our values that we're using to estimate, because we don't know what the actual values are. Finally, for the mode, again, we're using the modal interval instead because we don't have the actual data. We don't know the actual data point. We're not going to say that the middle or the midpoint is our greatest value. What we can do though is say, okay, which one has the highest frequency? Well, that would be the 15 to 20. So that means that 15 to 20 is the modal interval. So 15 to 20 is the modal interval. Next, the last example we're going to look at is looking at a weighted mean. And we've kind of already looked at this a little bit before when we did some of the probability distributions. We looked for the weighted mean. But in this example, your mark in class is calculated as follows. Right before you enter exams, you have, marks are, quizzes, 10%, assignments, 20%, project checks, 5%, final culminating is 15%. Tests are 35%, and then your final exam is 15%. So if I need to calculate the mean, it's a little bit different because we have different values, right? Or different values carry a different weight. They aren't all equal weighting, which is what we were assuming in the previous ones. So in this case, before you enter exams, you have an 82% on the test, right? You have a 91% average assignment. You have a 72% average assignment or quiz assignment. You got 100% on your checkpoints and 94% on your culminating. So if we want to calculate the mean, we have to do it a little bit differently because we have to use or introduce the weights. So what we do, the average or X bar is the sum of each data point multiplied by its weight, or the weight factor, divided by the sum of weight factors. So if you don't include or if you don't have all values, you don't divide by the total, right? So our total in this case would be 100% if we're adding them all up. But if we don't have a certain category included, we can't use that as one of the sum of weight factors, right? So let's say we don't have our exam. We're not going to use the 15%, right? So it would technically be 85% as our sum for weight factors. But we'll go through and we'll look at an example. So what is your weighted mean before the exams? Right? So before the exams, okay, that's where we're using that formula, the sum of, or x bar is equal to sum of each value or each data point multiplied by its weight divided by the sum of weight factors. So if we go back and look at it, here, we take our first value. So we have 10%, or we have, 82%. 82% times our quiz marks, right? 82%, test marks, my mistake. 82 times 35. Here you don't have to worry about turning things to decimals. So 82 times 35 plus the next one. So your next thing is 91 on your assignments. So 91 for the mark multiplied by 20 for the assignments plus your quiz marks. So 72 for your quiz times 10 for the weight plus 100 for your checkpoints multiplied by 5 for the weight plus 94 on your culminatings multiplied by 15 for the weight divided by the sum of weight. In this case, it is going to be all the values that all the weight factors that we added up. So 35 plus 20 plus 10 plus 5 plus 15, or we can say it's 85 because, again, that is all the weights except for the exam, and all the weights should add up to 100 in this case. So if we go through, give me a second to calculate this. We'll use the power of technology. So when we add everything up, we should get 7,320 divided by 85, and we get a weighted average of 86.12%. So that is your weighted average or weighted mean before exams. Now, how is this weight or weighted mean different from the unweighted mean? Right? So how would this be different than if we didn't include weight? Right? So in this case, we would just do 82 plus 91 plus 72 plus 100 plus 94 and divide it by 1, 2, 3, 4, 5. 5 different categories, 5 number values. We'd end up with an 87.8% for the unweighted average. Right? So relatively the same either way, off by a percent or two either way, depending again on the weighting of the categories. Because these ones are all relatively equal for the most part, your unweighted mean wouldn't be affected too much. Right? But if you were extremely low in, say, the test scores, right, or because your overall marks are all relatively the same, it kind of balances out. So it might not always be this close. The weighted mean might be a little bit higher or lower depending on, again, the weights of the different categories. So lastly, we're now asking, okay, what mark do you need on your final exam to finish with 85%? Well, if we're then looking at this 85%, we want this to be our average. We want this to be our X bar. So if we were to go through and do everything that we just did, right, our X bar would equal, again, the sum of each data point times the weight divided by the sum of weights. We now want our average to be 85. We don't have to go through and do all of the calculations again because we know it from the previous one. 7320 was the sum of all the other ones, and now we're going to add something. We're going to say an exam mark multiplied by 85. Right? Or we can say, no, sorry, not 85. An exam mark, which was 15, times whatever that exam mark is. Right? So that comes from exam weight. And we have an unknown exam mark. So we're dividing now by 100 because that is our total weight factor, because now we've included in the 15. So now we're just going through and solving. So now we have 8,500 equals 7,320 plus 15e. Move the 7,320 over. Subtraction. And we're going to end up dividing by 15 to get E. And when we do that, we get 78.6 repeating for our exam mark. So we need a 78.6% on the exam to get an 85, right? Which makes sense because we're allowed to drop a little bit because we are above that 85. So if we get a 78.6, we will end up with an 85. So this is something that you can do when you're going through and trying to figure out what you need on the final exam, because you have you should have most of your marks in. If not, you know which ones you can exclude, or you can make assumptions on how you think you did. But again, the main thing from this is just reviewing mean, median, and mode. For the most part, they should be relatively straightforward, except for maybe those two little examples at the end where we had kind of intervals or we had a weighted mean. So just two different scenarios that you might want to kind of refresh yourselves on or practice, which you can do in the home.